Okay, let's go through this unit circle worksheet. So step one is that I want you to fill out one of these three. Now again, one of these, not all of them. So it's however you want to do it. If you want to memorize the unit circle, go ahead and fill that out to your heart's content. If you want to do triangles like I do, this is my preferred method, is to do triangles. And then a lot of people also like the table, so you want to do the table there. So only fill out the one you're going to do. I'm going to fill out these two because these are the most popular. So let's start with my triangles. So this is the way I like to do it. It's memorize the triangles. So let's fill out these sides. So if you do the triangle, you have to have the triangles memorized. So 30 is the smallest angle. Opposite that's the 1. Hypotenuse is always 2. Adjacent rad 3. That's the exact same triangle at 60. I like to keep them separate. I think it's a little easier to understand when you look at them as separate things. 60, opposite of that's 60 is the biggest. Opposite of that's rad 3. Hypotenuse is 2. And adjacent is 1. 45 is a special triangle. It's a 45, 45, 90. So this is isosceles. So both sides are 1. And the hypotenuse is 2 again, but in this case it's radical. Right? 2 is always an hypotenuse. Only time it's radical is when it's 1, 1. When these are the same, it's 1, 1, rad 2. So that's the triangle method. For the table method, it's all about filling out the first column right here. So you get that memorized, and the rest of it's pretty easy. So it starts off as sine of 0 is 0. Then we go 1/2, and then 2 over 2, 3 over 2, and then 1. And that's a radical 2 over 2. It actually just kind of follows. It's 0, 1, 2, 3, 4. That's kind of where it goes. So rad 4 over 2. But then rad 4 over 2 is 2 over 2, which is 1. So it just kind of climbs. So 0, 1, 2, 3, 1. And that one's a radical. Now cosine is just flip it upside down. So if you know this column, you know this column by just flipping it. So 1, rad 3 over 2. By the way, I forgot that. Rad 3 over 2. Rad 2 over 2. 1/2 and 0. So you have cosine. All we do is flip it. So again, sine is 0, 1, 2, 3. 2 and 3 are radical. Technically 1's radical also, just radical 1 is 1. And 0 is radical, but rad 0 is 0. So you get that. And then cosine, you just flip it. Now for tan is sine over cosine. So you're just going to put sine over cosine. 0 over 1 is 0. 1/2 over rad 3 over 2 is going to get you 1 over rad 3. Some people call that rad 3 over 3 if you rationalize. I don't care either way. Rad 2 over rad 2 is the same thing, so it's 1. Rad 3 over 2 over 1 over rad over 2 gets you just rad 3. And then 1 over 0 you cannot divide by 0, so it's undefined. So the table, that's how you set up the table. Don't forget, if you're doing the table, you need to know all students take calculus. We'll get to that when we do those problems though. This lets you know where stuff is positive. In quadrant 1, everything's positive. In quadrant 2, only sine is positive. Quadrant 3, only tan is positive. Quadrant 4, only cosine is positive. I mean, that works for either way. You can do that with triangles also, or also with this. So it works for everything. So we're going to do some of these. I'm going to pretty much just do the triangle method. I might do a couple of tables in there. So sine of 60. So remember the sets where you draw a little triangle, 60-degree triangle. So here's 0, here's 90. So you want to draw where the angle is at. So 60 in quadrant 1. And then you make a little right triangle with the reference angle. So you always want to go to the x-axis. Always to the x. I cannot stress that enough. You gotta know when people go to the y. Reference angle is on the x. A little right angle there. This is 60. Now if you're doing the triangle method, now you just gotta remember what all the triangles are. 60 is the big one, so opposite is rad 3, hypotenuse is 2, and adjacent is 1. SOHCAHTOA, since I'm asking about sine is opposite of hypotenuse. Here's my angle, so opposite would be rad 3, hypotenuse would be 2. So rad 3 over 2. And there we go. So that's the triangle method. Now if you're going to do sine of 60 with the table, that's from one of the easier ones. It's on there. Sine 60, rad 3 over 2. Cosine of pi. Again, these are ready. So draw it. It's always step 1. Here's 0. Here is pi. Pi is on the line. So we call these quadrantal angles. They're actually on the line. They're special. So what you do, the ones that fall on the line is, you remember the point. This is a unit circle. You go over 1, it's 1, 0. You go up 1, it's 0, 1. You go to the left 1, negative 1, 0. And you go down 1, 0, negative 1. So we're looking right here. And then how do you tell if you look at the x value or the y value? It's cosine. Right? So if you remember from the notes, sine e, cosine x. Sine is the y value, cosine is the x value. Since we're doing cosine, we want the x value, so -1. And then if you wanted tan, by the way, tan is sine over cosine. So in this case, that would be y over x. Because tan is sine over cosine. So that's how that one works. If you're doing it on the table, you don't have pi over 2. You don't have pi. They don't have stuff on that side. So what you do is you look at what's opposite of it. Opposite of pi is 0. So cosine is the same as 0, which would be 1. But since on the opposite side, you make it negative. So -1. 10 to the 3 pi over 4. So key things drawing it. So here's pi. Remember the trick is always if you want to draw it, you make this 1. So 4 over 4. And then 3 pi over 4 is 1 less. We haven't got there yet. We're a little behind, so we're in quadrant 2. That's 3 pi over 4 right there. It's over 4, so we should know the reference angle automatically. It's 45. And then I just got to figure out the sides. Opposites 1. Adjacent 1. Hypotenuse is rad 2. Now there's one thing here. Since we're doing tan, you're going to, not since we're doing tan, sorry. Since we're going to the left, it's an XY graph. If you go up, positive. You go right, positive. If you go left, you're negative. If you go up, you're positive. So this is a positive one. You generally don't write positive one, but I just want to show the contrast between positive one and negative one. Hypotenuse is always positive no matter what. I don't care if it's up here, down there. Hypotenuse is always this positive value. So what's tan here? TOA. Opposite over adjacent. 1 over -1. So -1. So there we go. Another way to check if you want to make sure you have the right angle is you go, okay, well, 1 over, so it's 1 over 1. How do you know if it's positive or negative? Well, it's in quadrant 2. Look at quadrant 2 here. Only sine is positive. Anything else? Tan, cosine, both negative. So I have a tan, should be negative. How you do this on the table? Well, all you look at on the table is a reference angle. Well, you want to figure out what quadrant it's in also, but you look at the reference angle. So draw it, draw the right quadrant, look at the reference angle, it's 4. Well, you have to know the radian, sorry. So it's V0, pi over 3, pi over 4, pi over 6, pi over 2. So you go pi over 4 is right here, tan is 1. And then how do you tell if it's positive or negative? What quadrant are you in? We're in quadrant 2, so tan is negative. Only sine's positive in quadrant 2. So that's how I do with the table. Okay, I'm going to move on. I'm going to do less of the table and start doing all this in a circle now. Sine of 5 pi over 3. Let's draw it. So 0, pi. Now it's 5 pi over 3. So this is 3 over 3. I got to get all the way to 5. So 3 over 3. 1 less would be 2. 1 will be 4. I got to get a 5. So 3 plus another 3. 6 pi over 3. And then 1 less, since we're going this way, 1 less is over here in quadrant 4. So there's 5 pi over 3. It's over 3, so we should know the reference angle. Over 3 is automatically 60. Then you should know the sides. Opposite, rad 3, because 60 is big. Hypotenuse is always 2. And a 1. Now, one of these things should be negative. You're going to the right, so that's positive. Hypotenuse is always positive. Rad 3 is going down, so that's a negative. And then we just do sine. So, opposite over hypotenuse. Negative rad 3 over 2. Cosine of 150. So again, we can draw it. Here's 0, here's 180. 150, here's 90. 150 would be in here somewhere. 150. Draw a right angle. Right, then the next thing I do is find the reference angle. So between 150 and 180, it's 30. Since that's 30, you gotta find you should know the sides. 30 is small, so opposite's 1. Hypotenuse is always 2. This is rad 3. What's my negative? We're going to the left, so this guy's negative. Right, it's like a normal graph. Up is positive, down is negative, left is negative, right is positive. We went left, so negative rad 3, and up is positive. Hypotenuse is always positive. Cosine, so ga So I need the adjacent side of the hypotenuse. Adjacent's this guy, hypotenuse is this guy. So negative rad 3 over 2. Next one, tan of pi over 2. So here's 0, here's pi. Pi over 2 is this point right there. Remember when I said if it falls on the line, that's a unit circle. You should know what point that is. You went over 1, you went up 1, so 0, 1. How do I do tan on this? Tan is sine over cosine. Sine e, cosine's y. Sine is y, cosine's x, sine e. So what do I have here? I have 1 over 0. Which you cannot do, undefined. No solution. Next one, tan of 210. So here's 0, here's 180, here's 270, 90. 210 will be over here somewhere. Right, so between 180 and 270. Remember, all I care about is the angle. So you make a triangle here. Always go to the x. Find your reference angle. This is 210, that's 180, so that's 30 apart. Find the sides. This would be a 1, opposite 30. Hypotenuse is always 2. The missing side is rad 3. So, what's my negative? Well, you went to the left, so this is negative. And you went down, so the 1's negative. Hypotenuse is always positive. It's always, always, always positive. So what do I need next? Tan. TOA. Opposite over adjacent. Negative 1 over negative rad 3. Or 1 over rad 3. Or if you want, rad 3 over 3. If you want to rationalize it and be a hero. There you go. Sine of 270. So we always draw it first. 0, 90, 180, 270, 360. 270 is down here. So it's on the line. Remember what I always said? If it's on the line, you got to find the point. What point is that? Well, you're going down. So your x is 0 and your y is negative 1. And then we're doing sine. Sine e. Sine is y. So negative 1. Cosine of 5 pi over 4. Again, we're going to draw it first. Here's 0, here's pi. Remember the trick is you make pi whatever number over itself, because that makes it 1. And then I go to 5 pi, I go a little bit past that. So I'm right here in quadrant 3. 5 pi over 4. We should know the reference angle is in radians. Over 4 is automatically 45, which makes the sides 1, 1, rad 2. Don't forget the sign. This one's negative. We went to the left. And this one's negative. We went down. My mistake. Left and down. So we're both negative. Hypotenuse is always positive. We want cosine. Ca. Adjacent over hypotenuse. So negative 1 over rad 2. Or if you want, negative rad 2 over 2. If you want to rationalize that. Multiply both sides by rad 2. Top and bottom by rad 2. Okay, the next one. The terminal side theta in standard position contains each point. Find the exact values of the 6 trigonometric functions of theta. So, kind of like the last one, but now we got to draw it ourselves. So, 0.12. So, right 1, up 2. So, what they want you to do here is make a triangle. Just like we always do. Down to the x-axis, from the origin to the point, then down to the x-axis. Now, what are these sides? Well, you went over 1, so this is 1, and you went up 2. So, this is 2. Find the hypotenuse. A squared plus b squared equals c squared. The only thing that really matters is c squared. That's the hypotenuse. That's what we're looking for. So 1 squared plus 2 squared equals c squared. I get 1 plus 4. I get 5 equals c squared. Square root it. C equals rad 5. So like that. Then when we found the 6 trig functions of theta. By the way, I never put theta. Theta's right there. Theta's the angle you're looking for. So there's my theta. So then with the 6 trig functions, we need sine, cosine, tan. Sine goes with cosecant. Cosine goes with secant. Tan goes with cotan. Okay, what is sine? Opposite over hypotenuse. So 2 over rad 5. What is cosine? Adjacent over hypotenuse. 1 over rad 5. Tan is opposite over adjacent. 2 over 1, or just 2. Cosecant. just the opposite of sine. So rad 5 over 2. We'll say rad 15. Secant would be the opposite of cosine. So rad 5 over 1, or just rad 5. And cotan would be the opposite, reciprocal I should say, not opposite, of 2. 1/2. Reciprocal. It's more mathematically correct. Not the opposite. Opposite would be like a negative. So reciprocal. So there we go. The same thing with this one. Negative 6 and 8. This is a different point, but the exact same concept. So you're going back 6, and then you're going up 8. So let's say this point right there. We'll make a triangle, so you always go straight down to the x-axis or straight up, and then to the origin. Now, I know my negative 6 is right there. That's actually a little wrong. Aw. Just want the 6 to go away. Right, you're going to the left negative 6, so this part's negative 6. And I went up 8, so this is 8. I gotta find the hypotenuse. We should know a 6, 8 triangle by now, though. A squared plus b squared equals c squared. 6 squared plus 8 squared equals c squared. You're gonna get 36 plus 64 equals c squared. You get 100. So square root that. C equals 10. Like that. So there's my angle. Now we just find all 6 trig functions. So you have sine again. You got cosine. We got tan. You got cosecant, secant, cotangent. Sine, here's my angle. Opposite of hypotenuse, 8 over 10. Cosine, negative 6, adjacent of hypotenuse, over 10. And then tan is TOA, opposite of adjacent. So opposite over adjacent, 8 over negative 6. And then all we do here is flip them. So 10 over 8, 10 over negative 6, or negative 10 over 6, and then negative 6 over 8. And there we go. Now again, this is the same thing, negative 10 over negative, same thing as negative 10 over 6. So you can put that negative anywhere, really. So it looks a little funky there to me, but it's the same, that's the same thing as putting a negative out. Anyway, that's how you do those. Here's another chart. We're not going to fill that one out. If you got it, you got it. That was just more in case you're doing it live. Let's do some more, because this stuff's fun. Sine of pi. So we can draw it first. Here's 0. Here's pi. So again, we have sine of pi. So we actually are on that point right there. Anytime you land on the point, you got to know the value of that point. So you went to unit circle. Right 1, left 1. Negative 1, 0. Sine e. Sine's the y value, so just 0. Next one, cosine 7 pi over 4. So we gotta draw it. So 0 pi. I'll make this 4 over 4. So that's 4 over 4. You gotta go another 4 over 4. You gotta get close to 7, which make it 8 pi over 4. That'll be 1 less. It's like right there. 7 pi over 4. Remember, you always go to the x-axis. In this case, I'm gonna go straight up. And then it's over 4, so we should know the reference angle. Over 4 is automatically 45, which makes the sides 1, 1, rad 2. I'm missing something though. One of these should be negative, and it's going right to positive, going down is negative. Hypotenuse is always positive, so it's like that. I need cosine, so ga. So here's my angle, here's adjacent, here's the hypotenuse. 1 over rad 2. Or if you prefer, rad 2 over 2. Tan to 2 pi over 3. As always, you gotta draw it. 0 pi. 3 over 3 is a trick. Right, whatever that is, make it over itself. And then 2 pi over 3, we haven't got there yet. We're a little short, we're in quadrant 2. And again, it's over 3, so I should know the angle. Over 3 is automatically 60. Since you know that, you should know the sides. Opposite is rad 3. Hypotenuse is 2 and adjacent 1. What thing's negative here? The 1. You went to the left. Hypotenuse is always positive, and then you went up. So now I need tan, TOA. So I need the opposite over the adjacent. So negative rad 3. The next one, sine of negative 150. Some negatives. So remember the way negative works? You go down instead of up. So we're going to go down counterclockwise, or clockwise instead of counterclockwise. So that's 0. That makes this negative 90. Makes this negative 180. So negative 150 between those two guys. Even here, we still do the same thing. We go to the x-axis and make a reference angle. Like that. 150, 180 is 30 apart. So we show the sides. Opposite 30 is 1 because it's the smallest. Hypotenuse is always 2, and then this is radical 3. What's negative? The rad 3 because you're going left, and the 1 because you're going down. Hypotenuse is always positive. And then we want sine. Just so. Opposite of hypotenuse. Negative 1 over 2. Cosine is 0. That's fun. So here's 0, and that's all I really need. It's also in degrees, so that should be 180. Okay, right here. So that's a point. Remember, it's a unit circle. You went right 1, so that is 1, 0. And cosine, sine e, sine is the y value, cosine is the x value. So this is the x value, so this is 1. Cotan 210. So again, we're going to draw it. So here's 0, here's 180, here's 270, 360. 210 should fall between 180 and 270. So let's draw a triangle there. Always go to the x-axis. So 210 and 180 is about 30 degrees. Or exactly 30. And then we show the sides. Opposites 1. Hypotenuse 2. Adjacent's rad 3. What's negative? Same thing we did last time, these two. And then I want cotan, so that's opposite of tan. So the easiest way to do this is figure out what tan is first. And then flip it to the reciprocal. So tan is TOA, opposite over adjacent. So tan equals negative 1 over negative rad 3, which makes tan, cotan, sorry, just the reciprocal of that, which is 3 rad 3. The negatives canceled out already. So cotan of my angle equals that. Okay, that's the next one. Another one of these filling out again. If you need to fill them out, fill them out. But I'm going to skip that. That's fine if you skip that too if you know it. Let's go to these next ones. So let's do some more evaluating. Sine of pi over 4. So when there's no number on top, it's in quadrant 1. So like 0, here's pi over 2. No number, so quadrant 1. Pi over 4, we should know what the angle is since it's over 4, so it's 45 degrees. Makes the sides 1, 1, rad 2. They're all positive because you're going right and you're going up. And then sine is so. So opposite over hypotenuse. So 1 over rad 2 or rad 2 over 2 if you prefer. Secant of 2 pi over 3. So how do we do secant and cotan, stuff like that? You just do the reciprocal function. You just do cosine of 2 pi over 3. And then once you get your answer, you just flip it. Find the reciprocal. I keep on saying flip. Yeah, you just flip it. Flip works. Anyway, secant of 2 pi over 3. Here's 0, here's pi. So this is 3 over 3, right? Always using a trick. That's 3 over 3. We had to get to 2 pi, so we haven't got there yet. We're going this way, we're a little short, so we're over here-ish. So there, that's a bad angle. So here is 2 pi over 3. And change color, it's a little muddy there. So there's 2 pi over 3. We show make a triangle out of it. We show what the angle is. Over 3 is 60. So that makes this rad 3, 1 and 2. It's a negative 1 because we're going to the left. So we need cosine, so ka, adjacent for hypotenuse. So we get negative 1 over 2. But don't forget that's cosine. We need secant, so you got to flip it. So negative 2. Tan of pi. Here's 0, here's pi. So it's that point right there. Remember, if it's a point, you got to know what point that is. Going to the left. So negative 1, 0, because we're doing a unit circle. Tan is sine over cosine. Or sine e, sine's y, cosine's x. So it's the y over the x. So 0 over negative 1, or just 0. In general, tan of the x-axis is 0. Tan of the y-axis is no solution. Sine of 300. I've done a lot of trial. I'll do all this one in table form, so I'll have to scroll up to the table. Forget it, I'll just do all triangles. Sine of 300, here's 0, here's 180, here's 270, here's 360. So 300 be between these two, right? Between 270, ugly 270, and 360. Remember, make a triangle, in this case to go straight up. We're going from, and that's 300. So we're going from 300 to 360. So that's 60 apart. That lets me know the sides are opposites, we're at 3, because 60 is big. Hypotenuse is always 2, and adjacent 1. What's negative? Only the rad 3, because you're going down. Remember, hypotenuse is always positive, and that's going to the right, so it's positive. Sine is so. So opposite of hypotenuse, so rad 3 over 2. Negative rad 3 over 2. Cosecant of 210. So that's the same thing as doing sine of 210. Then just find the reciprocal. So here's 0, here's 180, 210 will be over here somewhere. Go straight up. Between 210 and 180 is 30. So I get 1, 2, rad 3. Both of those are negative because you went to the left and you went down. Hypotenuse is always positive. Sine is so. So negative 1 over 2. Again, we're looking for cosecant, so you got to find the reciprocal. So just negative 2. And then tan of 135. So again, we're just going to draw it. Here's 0, here's 180. Here's 90, 135 is in here somewhere. Make a triangle. How far apart are these two? About 45 apart. So I get 1, 1, rad 2. Remember this, because it's isosceles, so 45, 45, 90, so 1, 1, rad 2. You're going to the left, so there should be a negative. And then we're doing tan, TOA. So opposite of adjacent. So negative 1. So there we go. Now this part. Okay, I love this part. So I want you to figure out what quadrant that this is referring to. So only cosine's negative. What quadrant does that mean? So how do you do this? We go, all students take calculus. So now let's look at, where is cosine positive? Cosine's positive at A, because they're all positive at A. And at C, because that's what the C stands for, only cosine's positive there. So if cosine's positive at these two, it must be negative at the other two. So in what quadrants is cosine negative? That's what this says, less than 0 is negative. It's at quadrant 2 and quadrant 3. Remember, this is quadrant 1, 2, 3, 4. So quadrant 2 and quadrant 3, cosine's negative. Let's do the same thing for sine. All students take calculus. I want to know where sine is positive, greater than 0. So we're looking for positive sine. Well, A is everything's positive at A. That's what A stands for, all. And then sine is positive at 2. So those two. Quadrant 1 and quadrant 2. This one, it wants both. It wants where's tan greater than 0 and where's sine less than 0. So I'll just draw one like this. Let's start, I'll do tan in green. Where's tan positive? Well, everything's positive at A, and tan's positive at T. Right, so that's where tan's positive, these two. A and T, tan will be negative at S and C, but I'm asking for positive. So I'll say this one and this one. Now I'll do sine. Let's do sine in blue. I want to know where sine's negative. Well, sine is positive at A, and positive at S, because S stands for sine. But it's negative at the other two, so it's negative at T and negative at C. So where's the only, so in this case I want these two. Right, so sine's less than 0 down here, tan's greater than 0 up here. So what's the only time I hit twice? T, quadrant 3. Quadrant 3 is the only one that's true for both of them. That's probably not the best way. I'll do another one right here. That's probably not the best way to show it. How about secant though? Well, secant is just do the reciprocal function. It has the exact same sine chart as cosine. So the sign doesn't change. So we just do that instead. So all students take calculus. So where's cosine negative? That's what it's asking about. So first I always say to myself, where's cosine positive? Cosine's positive at A and at C. Because that's what A stands for, all of it, and cosine stands for C. So it must be negative here and here. And that's what I want. I want negative. So 2 and 3. Okay, let's look at this one. I'll try to do it this way. We'll do two separate ones. It might be a little easier to see if I do two separate ones. So let's do cosine first. I want to know where cosine's positive greater than 0. So cosine's positive in these two. Right? It's positive at A and it's positive at C. I want to know where sine's negative. Well, sine's positive at A and S, so where's it negative? At T and C. So what's the only quadrant I'd circle twice? That would be quadrant C, which is not called quadrant C, it's called quadrant 4. And that's the idea behind that. I think we have one more page left though. So last page, again, doing that again, I'm going to skip that because by now you should know how to do that. So let's do these and then we'll be done with this worksheet. So we got to find the quadrants for each one. Do I want to do this and by the table? I might do this whole last one by using the table because I haven't done a lot of the table for people that like the table. So let's see, I'm going to make the table up again. So first, let me do the angles, the radians. Pi over 6, pi over 4, pi over 3, pi over 2. Okay, and then I got to start with sine. So remember, it starts at 0. So 0, and then 1/2, and then rad 2 over 2, rad 3 over 2, and then 1. Then for cosine, I just flip it, or co, as you can read right there, my cosine. Just flip 1, rad 3 over 2, rad 2 over 2, 1/2, and 0. Then tan is sine over cosine. So 0 over 1 is 0. 1/2 over rad 3. Basically, 2's cancel each other out. You just get 1 over rad 3. Or some people like to put rad 3 over 3 if they rationalized it. These two are the same, so I just get 1. Rad 3 over 2 over 1/2. The 2's basically cancel out again. I just get rad 3. Then 1 over 0. You can't do that, so it's undefined, no solution. So like that. So let's look at the first one. So that's how we do it in radian mode. It'll use it in the table. So first part, you start out the same way you want to graph it. So 0, 180. This is secant before I do that. So remember, that's the opposite of cosine. We're going to get our cosine answer, reciprocal cosine. We're going to get our cosine answer, and we're just going to find a reciprocal. So here's 0, here's 180, here's 90. So 120 be in quadrant 2. And then you go, okay, 120, 180, that is 60 degrees. So if I was using the triangle method, I just figure out what the sides are. If you're doing the unit circle, if you're doing the table method, you go, okay, well, now I know it's 60. You go up to here. You go 60, we're doing cosine because we're going to flip it. Cosine of 60 is 1/2. So 1/2. You do got to do an extra step of figure out what sign it is. Is it positive or negative? We're in quadrant 2, right? All students take calculus. Only S, sine, is not secant, sine, is positive in quadrant 2. So we have cosine, so it's negative. So that's cosine of 120, and then we got to flip it because it's secant. So negative 2, like that. That's kind of the idea. So again, I'll try to do all these with the table. So the next one, cosecant of 7 pi over 3. So again, first we're just make that like sine. That's not reciprocal cosecant. 7 pi over 6, sorry. We draw it. Now you might go, why do I have to draw it for? I know it's 6, I know it's 30. You want to know what quadrant it is for this positive or negative. That's the only reason we draw it, to know what quadrant it is. So here's pi, here's 6 over 6. So 7 pi over 6 will be a little bit past this, will be in quadrant 3, so they go past 6 over 6. So we're in there, that's 7 pi over 6. So we're in quadrant 3. So with sine of 7 pi over 6, or with sine of pi over 6, which is 30 degrees, sine is 1/2 again. Is it positive or negative? All students take calculus. Only tan is positive in quadrant 3, and we're doing sine, so it's the negative 1/2. But really, we're doing cosecant, so we got to flip it. So, negative 2. Cosine of pi over 2, that we're actually lucky. That's on the grid itself. Pi over 2, cosine 0. If you're wondering why, if you actually draw it, pi over 2 is right here. That's the 0.01. Cosine's x, so 0. But again, if you're using the table, it's right there. It's right down there. Tan of pi. Oops. So tan of pi is right there. Now in this case, if you look at the table, it's not on there. There's no pi on the table. So when that happens, it only happens a couple times. with pi and then 3 pi over 2, you look at the one opposite of it and then you change the sign. So opposite of pi is 0, so we're looking for tan of 0. Tan of 0 is 0, and then you have to make it flip the sign, make it negative, which negative 0 is still 0. So this is going to be 0 no matter what. Again, if you're doing it the other way, then you just a point and then you do y over x. Secant of 3 pi over 4. Man, I got a lot of secant and cosecants. So this is again like the opposite. Look at sine of 3 pi over 4. Then we'll just find the reciprocal. And again, I gotta draw, just figure out what quadrant it's in, so I know it's positive or negative. So here's 0, that's a bad 0. Here's pi, make that 4 over 4. 1 less is right here. Right here. So 3 pi over 4. That makes me know it's 45 degrees, or 3 pi over 4. Quadrant 2. We're doing sine, right? Yeah, sine 3 pi over 4. So sine of pi over 4. So sine of pi over 4 is rad 2 over 2. So rad 2 over 2. I gotta check if it's positive or negative. All students take calculus. We're in quadrant 2, which is S. And we're doing sine, so it is positive. S and sine. But then we are doing secant, which is actually not sine, it's cosine. What am I doing? So we are negative. Cosine 3 pi over 4 is actually also negative 2, rad 2 over 2. That was such a bad mistake. Secant goes with cosine. Anyway, so it is negative because we're in quadrant 2 and only sine's positive. And then I gotta flip it. So if you flip this, you get negative 2 over rad 2. Or just negative rad 2. Cosecant 330. None of these cosecants. Remember step 1, do the reciprocal. So this is sine. Not gonna mess it up again. Draw it. Mainly just know what quadrant you're in. And find the reference angle in this case. Here's 0. Here's 180. 90. 270, 360. So 330 will be between these two. Make a little triangle, figure out the reference angle, that is 30 degrees apart. So 30 degrees in quadrant 4. So 30 degrees for sine is 1/2. So we should get 1/2. Figure out what quadrant it is, figure out the sine. All students take calculus, we're in C. So, and again, we're doing sine, that stands for cosine. We're doing sine, so that's negative, since we're not, they don't match. And then, I gotta flip it to be cosecant, so it becomes negative 2. Okay, last couple. 10 of 90. Again, another one I don't have to draw. 10 90 is up there. Here's 10, here's 90, undefined. Cosecant of 45, negative 45, almost add up. We can do sine of negative 45. Again, we draw just to know what quadrant it is, because that does matter if it's positive or negative. So negative 45, I mean to go down, so we're going to be in quadrant 4. So again, go down, not up. So what is sine of 45? Sine of 45 is rad 2 over 2. We are in the wrong quadrant though. We're in quadrant 4, which is only cosine's positive, so it's a negative rad 2 over 2. And then we're doing cosecant, so we have to find reciprocal, flip it. So negative 2 over rad 2. Or if you want to rationalize it, negative rad 2. Cosine 3 pi over 3, it's an easy one. That's on the table, straight out. Here's pi over 3, here's cosine 1/2. Done. Again, if you do that with the triangle, you just go pi over 3 is in quadrant 1. 60 degrees, opposites rad 3. Jason's 1, hypotenuse is 2. So gotta tell what. So either way you get the same answer. And that's the video.